This is Mastering Mathematics with your teacher, Karen Weston.
Good evening, everyone. I'm Karen Weston, the Mathematics Officer from the Ministry of Education. Welcome to the new series of Mastering Mathematics produced by the Education Broadcasting Unit in association with ABS Television. As you're aware, I have been away for quite 4 years now at the University of Nottingham, where I went and said I wanted to come back to Antigua with new teaching strategies for mathematics. Here I am, and I'm ready for you. If your neighbors are not watching, if your friends are not there, call them, get your paper, because you're never too old to learn, and I am ready. We're going to take it right from the beginning, and it's just mathematics, mathematics, and more mathematics. You are going to know it. I am angry, I am mad, and I'm ready, I'm furious. Mathematics must be number one in this country. Today, I'm going to start you from the beginning, and of course, everything starts with our number system. When we hear mathematics is so difficult, these are the things that they want us to believe will provide us with difficulty. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks familiar. These are the symbols that we use in order to get over what we're trying to teach you in mathematics. Today, I'm going to start with the number theory, because as you know, for us in Antigua Barbuda, we are using what we call the base 10 or decimal system. Base 10. All right? I don't want you to believe that base 10 is the only base that is in use in mathematics. Because as my friend from Ghana would tell you, that in their system, it's a base 5. What I can show you is that although we are saying that 1, 0 is 10, it is not necessarily true for all the other bases. Because as you're going to see, when I show you some examples, if I was doing a base 2, my units would be 0, 1, and then I'll be going on to 1, 0. I want you to keep your eyes on something. If I was saying a base 3, I would be going 0, 1, 2, and then 1, 0. And just another example, a base 4. And this would take us to 0, 1, 2, 3, and then we'd be getting 1, 0. So as you can see, every time you get the bases, the name of that base, when represented in its own system, is 1, 0. Therefore, base 10 has been given the name, 1, 0 has been given the name 10 in the unit that we are using. But it is common to all the different number bases. Today, I will be concentrating on the base that we use in our system, which is the base 10. The units 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like everything else in nature, must conform to some rules. And the first thing we try to teach our students, and I'm talking about our secondary students so far, we try to teach them, and not even the secondary, we take it right from the beginning, and you go from the primary, and we try to teach them to add, subtract, multiply, and divide numbers. It would be crazy if everything and everybody did what they like. So what do we have? We have a sequence in which these things are done. And so we get into this word that we call BOMDAS. And for different writers, it can be BODMAS, and for others, it can be BOMDAS. Today, I'm choosing to use BOMDAS. I decided to jump ahead a little here in terms of giving you the sequence in which numbers are done, and I looked upon and worked in terms of mathematics because I know my fifth formers are listening. I also want the parents to listen too. So, what is this BODMAS all about? And it says, when we are approaching these numbers and we see them in problems, we have to work them in a particular sequence. And the B stands for bracket. Sometimes we have the word of, so the O represents that word of. And then here comes the operations. We can get multiplication. I want to put a slash with division too, because somebody will tell us all the time, and the Americans will do that too, that division is just the inverse of multiplication. And that is why sometimes in certain operations for mathematics, it is not really distinguished or talking about separate from multiplication. So then we can have multiplication slash division, okay? And where I want to say division is equal to the inverse of multiplication. And then we get on to finally our addition. Which is A. And lastly, the subtraction. I wanted to come to BOMDAS right away because I would argue that and claim that most of the problems that students experience in mathematics comes from this, has its root in this particular operation. If we don't get this right, everything else we do in mathematics, in terms of working a problem, looking for accuracy, will be down the ladder. This is what we have to pay attention to right from the beginning. If we don't get anything else right in mathematics, here is where we have to start. And that is why at this early stage, I wanted to introduce you right away to mathematics. We have our numbers. These are the tools that we're using in terms to portray this lovely subject of mathematics. It follows a particular pattern and sequencing in terms of the operation, and this has been given the name BOMDAS or BODMAS. It means when we have an operation, we're looking to see, is there a bracket? We must address that first. Is there the word of? Then that comes in next. Multiplication, or we can choose to turn the division into the inverse of multiplication, and then that is done next. The addition comes after our multiplication, and last of all, our subtraction. Friends, most of our problem lies in these three areas: multiplication, addition, and subtraction. In law, in nature, there is order in everything that we are doing, and if we don't get this right, this is where our problem begins. So, take a few minutes, look and see what I've said. Write it on your papers, make certain you have it. I am here and I am going to bring to you how easy mathematics is. For our students in school, your examination papers are the only thing that the examiners have to talk to them, and you must do it on that paper in a logical and orderly sequence. So that's the first thing in terms of our mathematics, that we introduce you right away to the tenets that are used. We're now going to take a short break. I've given you so much in such a short time that I'm giving you space to breathe. Then we'll be right back when I will start introducing you to place values.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Welcome back. I know you're staying with me to the end. Did you call your friends? Right, because the mission has just started and we're not going to finish until every grandson and granddaughter knows mathematics and it's a part of their life. Right now, so we have given you mathematics, the base system that we are using. You already know the sequencing, how the operations are to be done. But as you are aware, like everything else in nature, we don't just have numbers sitting and floating in space. In order to make use of them, we have to give them a value. And that is where our place value comes in mathematics. Oh, yes, it does. This can be looked upon as an imaginary number line. And in terms of reading our place value, it is usually from left to right. And we start with what we are calling units. Then the name of the base is given, tens. And then we're going hundreds, taking you just up to billions. Unit, tens, hundreds, then we go to thousand. And then you're going to tens of thousand. I would also like to tell you that everything coming to the right of this line here, my right of this line here, these we'll be calling to as whole numbers. So right after this, I'll be getting into the names of the different types of numbers once we have them in this particular setting. Because every time you have a child in the family, what do? You give it a name. We do the same thing in mathematics too. So we have different names for the different numbers, and you will be introduced to that too. But let's get back to our place values. So we start with our units, and if we introduce it with our base 10, this is usually represented by 10 to the 0. And later, when I'm going to be doing certain operations, when I bring indices into the program, you'll be seeing why 10 to the 0 is always referred to as 1. Anything to a power 0, because we call this little number at the top of a big number an index, okay? And there is going to be a topic where we are going to be talking about indices, which is the plural to the word index. All right, so we go 10 to the 0, that is our units. 10 to the 1 would be tens, 100, 10 squared, and you can see a pattern going up, and that is what is done. I wanted to bring out this too, because sometimes our students are asked just to peep over the fence and to use the different number bases. I want to let them know that the principle is the same as that for the base 10. So every time we get a different number base, we have to translate it into the form that we are accustomed to, which is the base 10. So that, for example, if I wanted to do something in a base 2, you would still be going along the same premise, saying 2 to the 0, 2 to the 1, 2 squared, 2 cubed, so that this